Hey everybody, Morgan, I'm back here. We're moving on to page 4 of the electrochemistry lectures, and we're going to talk about something that's not often talked about before. This is not an AP topic, but it's an important topic because it does get used in some other outlets. And this is the idea of line notation. And this is just a fancy way of writing out how an electrochemical cell works. Okay? Now, first off, in line notation, we always put the anode on the left and the cathode on the right. Okay? So in the Danielle cell, as an example, the reaction Zn plus Cu2 plus gives us Cu plus Zn2 plus. Okay? How would we write this? Well, the shorthand notation tells us we have to look for the oxidation, the anode. Anode is oxidation, put it on the left. You have zinc. You draw a vertical line which indicates chemical reaction, like a phase boundary. Okay? And then Zn2 plus. The zinc turns into zinc 2 plus. That's actually in a different phase, hence the phase boundary. Okay? Some people like to put the AQ in. Then a double vertical line. That indicates a salt bridge. Salt bridge. Okay? Then we have the cathode, which is the reduction, Cu2 plus aqueous. Phase boundary, it turns into Cu, and we can put that as a solid if you like. Okay? So that is a line notation. So what if we have one that involves a gas? Zinc plus 2H plus aqueous, that's a solid, to give us H2 gas plus Zn2 plus aqueous. What we would do is we'd still start it out the same way. Zinc, vertical line, zinc 2 plus. Boom, boom. Okay. Then what we would put here is H plus. Sometimes people even, in addition to putting like the aqueous and the solid, might even put like a concentration. 1 molar aqueous. Line, H2. Line, platinum, because platinum is the catalytic surface upon which that reaction was happening. And we drew a lot of pictures of that back on bottom of page 2 and top of page number 3, showing that platinum electrode. Okay? We can even do it for what is called a concentration cell. Well, in a concentration cell, what happens is you have the same metal on both sides, but you have it at different concentrations. So one's concentration will go up one side, the other side will go down, and they'll meet in the middle. So we could do this by writing like zinc, vertical line, zinc 2 plus, and say 0.10 molar, double line, zinc 2 plus, 1.00 molar, line Cn. Okay? So that's some interesting notation for how to do these. You might encounter it, you might not. So important that we talk about it, but I wouldn't lose any sleep on it. Okay, so now to sum up pages 2, 3, and 4 in one of the most important little boxes we can write for all of chemistry. The 3 things we can use to determine spontaneity. KEQ, for a spontaneous reaction, is bigger than 1. Delta G is negative, and E naught is positive. KEQ is less than 1 for a non-spontaneous reaction. Delta G is positive, and E naught is negative. And what this is basically telling you, some professors might get angry that I say it this way, but KEQ, delta G naught, and E naught are the same thing, expressed different ways with different units. Okay? So we're going to be able to convert between these two without a whole lot of problem. The math is going to be pretty straightforward. Okay, so that's a nice short video for page 4 of the lecture outline. We'll be back with page 5 next time. It's Morgan signing off.